right, this is piecewise functions continued. We did examples 1 and part of example 2 in the previous video. All right, so we're going to start here where it says graph the function, find the domain and range. So y equals x plus 1 if x is less than or equal to 0. So here's our x-axis. Less than or equal to 0 is to the left of 0, less than or equal to 0. So we need to graph this function. The point at 0 will be included this time. So we're going to have y equals x plus 1. 1 is our y-intercept. We're going to have a solid point since it says x less than or equal to 0. So this is my x at 0. So 0, 1 is the y-intercept. That point is included. And now we need to graph our line to the left of, less than or equal to is to the left of 0. All right, so we have a slope of 1. That is a positive slope. If I go up 1 over 1, I'm going the wrong direction. So I need to go down 1, back 1, down 1, back 1, and continue using my slope to go to the left of 0. All right, I can take and now graph an arrow. And that is this first function graphed. Now we need to graph y equals negative x for x's greater than 0. All right, greater than 0 means everything to the right side of the y-axis. All right, so when it has negative x, that means negative x plus 0, so the y-intercept would be 0. This time that point is not included. So I'm going to make this an open circle to show that it starts there, but that point is not included. All right, and it has a slope of negative 1. So that means it's going to be going downhill, negative 1, down 1 over 1, down 1 over 1. So down is negative, to the right is positive. So negative over a positive is a negative slope. All right, we're also going to draw an arrow here. And that would be our piecewise function graphed. Again, open circle and a closed circle. You use the vertical line test. The fact that one is open and one is closed, where they overlap, means that it is still a function. All right, it does say find the domain and range. All right, so the domain of the piecewise function, meaning both of these lines together, it goes to the left forever, to the right forever. So your domain would be all reals. All right, you can write that as negative infinity to infinity. Your range is your y values. Your y values is your vertical axis. You can see that the highest point on the range is at positive 1, and it's everything less than or equal to positive 1. So we're going to write y less than or equal to positive 1. All right, now in the last video we did graph number 2, but I forgot to do the domain and range. So let's go back over here. Domain, you can see again going left and right. Your x's go on forever. So we're going to have negative infinity to infinity. And our range is our y values. Our y's go down as low as 1, 2, 3, 4. 4 not included. So all y's greater than 4, not including 4. Okay? All right, that is all for example 2. Both examples are graphed and shows the domain and range of each. All right, example 3. Now we have to be able to write a piecewise function. So write a piecewise function represented by the graph. All right, so when we first look at this, we can see that each one of these is represented by a line, which means each one of these is linear, and we already know how to write linear equations. So that's good. All right, so let's start with the left side, okay? And then we'll come back and do the right side. All right, so let's determine what the equation is for this line. So we can see 1, 1, up 1, over 1. So we can see that it has a rise over run of 1, which means this one has a slope of 1. And it has a y-intercept of 1, 2, 3. Now it hits at 3. That's not going to be included in the domain, but that's still important for the equation. All right, so the left side we can determine that that is y equals 1x plus 3. All right, let's see what the equation is for the right side. All right, so the right side has a slope of rise 1, 2 over 1, rise 1, 2 over 1. So the slope is 2, and the y-intercept is -1. So this one has an equation of y equals 2x plus 1. Now we have to be able to write this as a piecewise function. All right, so this is, let me take and temporarily I'm going to move this out of the way. All right, so we're going to write our piecewise function. All right, so a piecewise function is going to be f of x. That's just using function notation. If you want to use y equals, that's fine as well. But f of x equals, and then they use this little bracket because it's more than one function. So this just shows that this is all one function. So f of x equals, and then we're going to put the first function here. And then right underneath it, we're going to put the second function. All right, then we're going to put the comma, and now we have to define the domain. Remember, the domain comes from your x's. Here's your x's. So if you look right here, the left side, it has an open circle at x equals 0. And it has every point to the left of that, so all the negative numbers are included. So if it has an open circle at 0, that means 0 is not included, but it's everything less than that. So we can write that as all x less than 0. All right, and then for the next piece, the next part of the function right here, this is a closed circle, so we know it's going to be x, and it starts at 0 too, but it's including 0, so it's going to be greater than or equal to 0. And that's it. Once you find the equation for the left side and the right side, you have the piecewise function. The only part left is to tell what part of the domain it's going to, where it's at. All right, let's look at this next example. Okay, this next example has 3 pieces. So that means we're going to have a left side, a middle, and a right side. So we're going to have 3 different functions here. All right, so let's start with the left side. And if I wanted to write an equation here, you can see that this has a slope of down 1 over 1, down 1 over 1, down 1 over 1. If it continued, it would have a y-intercept of -2. Now it doesn't continue, but that's still what the line, part of the equation, you need the y-intercept to write that. So we're going to have the left equation is getting ahead of myself here. All right, so the left equation is going to have a slope of, you can see that it's going down from left to right, so it's down 1 over 1, so a slope of -1. And the y-intercept, again, if that line continued, would hit at -2. So the y-intercept would be -2. So that left side would be y equals -1x minus 2. Now, this middle line is constant. So the middle, that's going to be easy. It's just going to be a y-intercept. There's no slope. So there's no rise. There's just a run. So it'd be 0 over whatever. So it's just that constant term. So 1, 2, 3, that's a constant term of 2. So this one's just going to be defined as y equals 2. And then the right side, all right, we need a slope and a y-intercept again. So if we look at this, we can say rise 2 over 1. So my slope is 2 over 1 or 2. And my y-intercept, again, we can't see it on here, but we can imagine what's going to happen if we go down 2 over 1. It's going to cross right here. So that's -1, -2, -3. So the y-intercept is -3. So even though that line doesn't go that far, you still need that piece of the information to write your equation. So y equals your 2x minus 3, and that gives you your 3 equations. Now we just have to put it all together. So let me see if I can move this over a bit. All right, so I'm going to have f of x. So I'm going to have -x minus 2. I'm going to have, that's my first one. My second one is equal to 2. And my third one is 2x minus 3. And then I just have to define the domain. All right, again, remember the domain is your x's. So you can see that this one includes -2. It's a solid circle there. It includes -2, and it's everything less than -2. So this is going to be all x's less than or equal to -2. All right, because this one goes from an open circle to an open circle, that means neither one of these endpoints are included. It's going to include all the x's in between those 2 points. So we can put x here. And we're going to use the less than symbols, not the equal sign, not the less than or equal, because these are not included. And to make sure that this is a function and it passes the vertical line test, these have to be open. All right, so this is -2. All I'm doing is looking at my x's here. This is x at -2, and this is x at +1. So it's going to go from -2 to +1. All right, and the third piece here, again, I'm looking at my domain, so just my x's. This is a solid circle. This is where the line starts. It starts at +1. So my x is +1. This is a solid circle, which means 1 is included. So it's greater than or equal to 1. And that's it. That is my piecewise function defined. So this was the answer for the graph here, and this is the answer for the graph here. All of this other stuff is just work, kind of helps you leading up to this, kind of look at each piece separately, which I think kind of helps. Like, don't look at the whole thing at one time, look at the different parts together, and it makes it a little bit easier to get to the answer. All right, if you have any questions, please let me know.